Lesson 8.3, Solving Right Triangles. The objective of this lesson is to use trigonometric ratios to find angle measures in right triangles and to solve real-world problems. In San Francisco, California, they have very steep streets. The steepness of a road is often expressed as a percent grade. Filbert Street, the steepest street in the city, has a 31.5% grade. This means the road rises 31.5 feet over a horizontal distance of 100 feet, which is equivalent to a 17.5 degree angle. You can use trig ratios to change a percent grade to an angle measure. Let's learn how. Use the trigonometric ratio cosine of A equals 24 over 25 to determine which angle of the triangle is angle A. And you look at our picture and we have angles 1 and 2, and then we have a right angle. So the first thing we need to know is the cosine is the ratio of the adjacent leg to the hypotenuse. So let's set up our ratio. Cosine of A equals an adjacent leg over a hypotenuse. The leg adjacent to angle 1 is 1.4 and the hypotenuse is 5. If we multiply both of those times 5 over 5, we get 7 over 25. This is not correct. The leg adjacent to 2 is 4.8 and the hypotenuse is 5. So 4.8 over 5 multiplied by 5 over 5 gives us 24 over 25. Thus, angle 2 is angle A. In the previous lesson, we learned that the sine of 30 degrees is 0.5 using the calculator. Conversely, if you know that the sine of an acute angle is 0.5, you can conclude that the angle measures 30 degrees. This is written as the inverse sine of 0.05 equals 30 degrees. This little negative 1 is not an exponent, it means the inverse of. If you know the sine, cosine, or tangent of an acute angle measure, you can use the inverse trigonometric functions to find the measure of the angle. Inverse trig functions are, if sine of A equals x, then the inverse sine of x equals the measure of angle A. If cosine of A equals x, then the inverse cosine of x equals the measure of A. And likewise, if the tangent of A equals x, then the inverse tangent of x will equal the measure of angle A. This we get by using the inverse function button on your calculator, which is the second function and either sine, cosine, or tangent. Using your calculator to find each angle measure to the nearest degree, we want the inverse cosine of 0.87. So we put it in, and our calculator will say inverse cosine of 0.87 is 29.5413605. We can round that. It's about 30 degrees. We want the inverse sine of 0.85, and this gives us approximately 58 degrees. We also want to find the inverse tangent of 0.71. Putting that into the calculator, we see that we get about 35 degrees. If we use the given measures to find unknown angle measures or side lengths, this is known as solving a triangle. Anytime we have a triangle and there's a piece of it missing, the measure of one angle, the measure of one side, we are solving the triangle. Let's try one. Find the unknown measures, round the lengths to the nearest hundredth, and angle measures to the nearest degree. So by the first method, which is the Pythagorean theorem, we're going to look for ST. We have RT squared equals RS squared plus ST squared. We fill in what we know. So 5.7 squared equals 5 squared plus ST squared. So ST equals the square root of 7.49, which is about 2.74. The measure of R, angle R, equals the inverse cosine of 5 over 5.7, which is about 29 degrees. Since the acute angles of the right triangle are complementary, the measure of angle T equals 90 minus 29, or about 61 degrees. Let's try another way. The measure of angle R equals the inverse cosine of 5 over 5.7, which is about 29 degrees. Since the acute measures are complementary, we still subtract and get 61. The sine of R equals ST over 5.7. So ST equals 5.7 times the sine of R, which would be the sine of the inverse cosine of the amount we were given, the 5 over 5.7, which is about 2.74. So we get the same length for the side. Let's solve another one in the coordinate plane this time. The coordinates of the vertices of triangle PQR are negative 3, 3, Q at 2, 3, and R at negative 3, negative 4. Let's find the side lengths to the nearest hundredth and the angle measures to the nearest degree. So step 1, we're going to find the side lengths. We'll plot the points P, Q, and R like this. And PR, because it's a vertical line, is 7 units, and PQ is 5. To find RQ, we'll use the distance formula. And we get that it is about 8.6 units. Step 2, we need to find the angle measures. PQ and PR are perpendicular, so that's 90 degrees for angle P. PR is opposite of angle Q, and PQ is adjacent to Q. So the measure of angle Q equals the inverse tangent of 7 over 5, which is about 54 degrees. The acute angles of a right triangle are complementary, so the measure of angle R will be 90 minus 54, or about 36 degrees. Let's use an application for travel. A highway sign warns that a section of the road has a 7% grade. To the nearest degree, what angle does the road make with a horizontal line? Let's change the percent to a fraction. 7% equals 7 over 100. A 7% grade means the road rises or falls 7 feet for every 100 feet of horizontal distance. So let's draw a right triangle to represent the road. We have 100 feet, and it rises or falls 7 feet in that time. Angle A is the angle the road has to make with the horizontal line, and the measure of angle A equals the inverse tangent of 7 over 100, which is 4 degrees. Now you try. Complete the you try assignment, label it 8.3, and make sure you put it in your folder for credit. And I'll see you next class.